Hello again, and welcome to my review of my Advent of Code 2024 solutions in ARM for the Game Boy Advance. Today we're looking at day 4. So what is our problem today? Today we are solving a word search where we only have to find one word. Xmas. Christmas. Okay, but we have to find all cases of the word Xmas, and they can be found horizontal, vertical, diagonal, backwards, or even overlapping other words. Right? Xmas, 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 they're all in there. So that's our part 1. Our part 1 is just looking for how many times we can find this Xmas string in our input. And this is actually a time where I do part 1 and part 2 separately. So let's look at part 1 first, shall we, in the code. So let's get rid of that. Let's bring, not missing yet. That one there. Alright. So, I gotta scroll back up a bit. Here we are. Now, I've got a few more labels in this one here. But I don't use path list, OBSD list, or test path. I think I've copied those back from day 5 actually, or another later day. That's alright. But this one that we really need is this one that I just deleted. Grid width. So what I'm going to do in this one, because I'm looking through a grid in memory, I'm going to keep that grid in memory. I'm not going to load it. I'm going to keep it on the ROM. I'm not going to load it into RAM. So what I'm going to do is this. So we load our input address. We make a copy of the input address for our bounds checking. See if we go out of bounds in R7. The end of our input in R9. We're going to use R10 as an offset to start off with. We've got our grid width. We load that memory address into R5, and we store 0 into R5 just to make sure that it's reset. And R6 is going to be our state again. 0 for when we're doing silver, 1 for doing gold, 2 exits. The first loop we go into this is find width. Right, we want to know how wide our grid is. So we're loading through our input, R8 with the offset of R10. When we find OA, which is a line break, we will add one more. We add one more to R10 regardless. We just add it regardless. And if R0 is not equal to 08, then we loop back. But if it is, then we store our R10 into R5, into that memory address, and we go into the main loop. So our main loop is actually relatively short this time. Just goes until there. We're looping until R8 is greater than or equal to R9. That will branch us to next stage. We load R0, and then based on the value of R6, we will either do the silver checks or the gold checks. And you can see I'm doing 2 compares here. You have to do the 2 compares because if you branch into BLE, if I branch into silver checks, then the state then the control register state when I come out could be different than when I just done that compare. So if it is different, I could end up doing the gold check before I should do the gold check. Right? So you have to do a compare twice in this case. But it's okay. Just generally when you're doing like a compare and then branch, especially branch and link, BL, you should compare again if you're going to do two different branches. Then it would fall down into increment offset and branch back to reloop. If I get to the end, it'll call next stage, which will add 1 to R6. If it's equal to R6 is now equal to 1, then it will branch into prep gold. Otherwise, it will fall through into finish day. Prep gold just resets. I don't know why. Why am I doing that? I should have just done. What I should have done was like R8, R7, because R7 is the beginning anyway. I don't think it would take any more time. I think it's still a single. I think it's still a single cycle instruction. That's all right. But reset the our reading cursor, and then go back to the loop. And this time we'd be doing the gold checks. All right. So let's check for silver first. Let's check silver first. So what we're looking for this string Xmas. Only my one's backwards. We're looking for it X M A S. But that's right. So we're going to the silver checks. Right, we branch in here. We compare R0 to 58, hex 58. That is the hexadecimal for X. If it's not X, then we just branch out. Right, then we exit. Right. All the results will have to have an X somewhere, and so I only look for run the check if I'm landed on an X. Now I think the way that I have done it, the way I have done this is that even if that X has multiple, that single X has multiple cases of Christmas coming out of it, it will catch all of them in this, so that should be alright. Okay, so the first thing I do, I back up our pointer R8 to R6 so I can use it all the time, and then I've got this UD check, up down check. I load into R4 the value of R5. Remember, R5 was the width of our grid. I'll give a visualization of this, shall I? Let's bring the browser back for a second. Let's have a look at this grid here, example grid. You see it's 2, 4, 6, 8, 10 characters wide. So, and then +1 for the line break, character return, and then one more. Well, no, it should just be that, shouldn't it? Yeah, 11, right? So if I want to check the character below, I'd take where I am now and add 1, 2, 3, well, and add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, line break, 11 to it. Right? So this memory address, I just add the width +1 of the grid to my present memory address, and I will get the character that is below my current character. And so then for the next one, I can add another 11, and I get to this character, and another 11, and I get to this character. And that's how I'm checking these, checking for the string, right? I'm adding a memory offset based on what direction I'm trying to look, what direction I'm trying to search to it each time. So the first one, going up and down, I just add the width of the grid. Let's get rid of the browser again. I just add the width of the grid. I put that into R4, and then I branch into this add 3. So let's have a look at add 3. Where's my add 3? There it is. Add 3. So I move these. R14 is my return address for the branch, so I back that up into R11 because I'm going to branch off somewhere else as well. I move R3, put 4 in there. I move R1 0. I load the byte where I am right now, which should be the X. I could have skipped this, like I could have loaded that in already, but it doesn't matter. I load that in. I do a balance check. I shouldn't really do the balance check on the first one. Who cares? Doesn't matter. Branch to the balance check. If I come back, because balance check is going to return on R2 whether I'm in bounds or out of bounds. If it's 1, it's out of bounds and would exit add, which exit add restores the return address from R11 and then branches back that return address. Right. So we load that byte, we've checked that it's not out of bounds, so then we add it to R1, we add to R8 this offset, right? In this case it's the width of the grid, and then we rotate R1 to the right. So we basically rotate the byte that's already in R1 to the right, and then subtract 1 from R3, and if it's not equal then we loop this again, so we're going to end up adding 4 bytes into R1. So add 3 should really be add 4, who cares? Don't worry about it. Let's check the balance check for a second. Where's my balance check at the bottom? Here we are. So balance check, first thing we do, we check if, we set R0 to we set R2 to 0. We compare R0, which is the byte we just loaded, to 0A. If it's 0A, that's the character for a carriage return. Then we're sort of hit the edge of our grid, the sides of our grid. So we've gone out of bounds. We compare R8 to R7, which is R7 was the start of our input. If we're less than that, we're out of bounds. Then we compare it to R9, which is the end of our input. And if we've crossed that, then we're out of bounds as well. So that's the balance checking. Okay, so if we come back from the add 3, and now we're checking R2 again to see if we were out of bounds. If we were out of bounds, then we'd go to the next check down here, LR check. Then we compare to this string up the top here. We compare, or we load into R0 this string, this value for Christmas, and compare it with R1. And if it's equal, then we go to branch to add silver, and either way, we will end up falling through into the next check. Right. So let's have a look at add silver. Add silver. We just get the address, the value. Well, we get the address of result 1. We load the value from result 1. We add 1 to it, and we store it back into there, and then we return to where we were called from. Right. So we do the up down check. Up down check is just the width of the grid. The next one I've gone here is the LR check. So we restore this this cursor position from R6, goes back into R8. The LR check is left to right. So left to right, we're just adding 1 to the memory address each time. Plus 1 to the memory address. So R4 becomes 1. We go branch into add 3, and the rest is the same, except that if we are out of bounds, we branch to the next DR check, which is down right. Down right check. So this time we have the width of the grid plus 1. That width of the grid plus 1. And so that will go downwards and to the right on that diagonal. And we do the same. And I delete lines like an idiot again. Right, and that's the same. The next one we have DL check, down left, which is also an addition one. This time we subtract 1 from the width of the grid. We subtract 1 from it. So the width of the grid minus 1 will go down into the left. Right, and the rest is the same. Okay, and then now the next one we have the DU check, down up check, so it's reversed. We're going upwards. And this time instead of add 3, we're doing sub 3, subtract 3. I could have, seeing we usually use, well, at least I'm using like signed bytes, and I'm using signed addition and all that. I could have used negatives and still use the add 3, I guess, but I'm not going to bother with that. Who cares? It's fine. Just make another one, right? We've got add. Where's there? It is. Here's sub 3. Sub 3. It's like almost exactly the same, except here I subtract R4 from R8 instead. But I mean, wait a second. That's not good. How does this work? This should be branch loop sub. So I'm suspicious at how this actually works now. I'm quite suspicious at how this actually works, because I do get the right result. I might have to rebuild this and make sure it's working properly. That's not one. Let me just make sure that this works properly. Yeah, get the right result there. Okay. Okay, we're fine. No worries. Okay, so apparently that could have been a massive problem. Alright. So yeah, we just subtract rather than add the offset in there. Alright. So now we're doing, what was it? That was down up check. Each of these RL check is now right left. So we're subtracting 1 from the memory address each time. Up left, we add 1 to the grid width, and now we're subtracting that each time, so that goes up and to the left. And then the up UR check, which is up right. So again, the width of the grid, subtract 1, and we're sub 3, so we're subtracting that each time. And this one here will actually branch to exit silver if it's not, if it doesn't match, if it goes out of bounds, and once we're finished it will also branch to exit silver because we're done the silver checks. Right, so that's going to do the silver solution. So let's have a look at the gold solution. So what have we got here? So apparently we misunderstood the assignment, right? We're not searching for Xmas, we're searching for an X-mas, right? In which you're supposed to find two MAS in the shape of an X. So one way to achieve that is like this here. Right, it's an X-shaped MAS. Right, so we have a look at this again. You got like this. Right, we've got a bunch of them around. Got MAS. There's like all over the place. Right, all sorts of ones in there. We've got 9 in here. So we need to find out how many times we have X-shaped MAS in our grid. So what am I doing now? So we finished the first time through the loop. We reset the to the start. We're going into the gold checks this time. So let's have a look at our gold checks. So now we're looking for a different thing. We're looking for this MMSS effectively. We're not looking for MSMS. I think there is a situation where, right? Because if you go for, well, the way I'm going to be loading it into memory is, or loading the characters into memory will be, sequentially around the central A. Right? I'm not looking for the A here. I'm not looking for MAS. I'm looking for MMSS. Right? So I'm going to find an A, as we can see over here. Like, I'm going to be looking for A's. Then I'm going to load the characters around the A from the corners. And then I'm going to see, and I'm going to do it like in a loop, like clockwise. Right? I'm not going to pick randomly around it. I'm going to do it sort of a clockwise manner. And so what I'll be looking for is like a sequence of MMSS, and that ends up in the register. So we start off. Let's say we've landed on an A. So first I make R1 a 0. I load the grid width. I subtract the grid width from R8. So we've gone up. We're looking up from it. Let's use this thing here. I'm going to use so this is, I'm on R8. I load the grid width and I subtract the grid width from my cursor position. So we're now here. Then I subtract 1, right? Then I subtract 1 from the position, and we're now over here, right? And then I branch to B check read. What's my B check read? B check read. Back up the return address. We load the byte into R0. We do a bounds check, right? Again, if we are out of bounds, we just exit because this A is not going to have a Christmas around it. There's not going to be a Xmas. If it is correct, if it isn't out of bounds, I'm restoring it now, but that's okay. Restore the return address, then I load, then I rotate R1 to the right by 8 bits, and we add that value, that character, into R1, and then we return. And then we come back here, assuming that we haven't we haven't been out of bounds. You come back here, I load. Why am I loading that again? It's not necessary. That there is not necessary here. Not necessary here, be necessary on the next one. This shouldn't be necessary. And this one down here isn't necessary either. Anyway, so the next thing I'm going to do is I'm going to add 2 to my cursor position, which will move it to here, +2, right? And we do that check, we load the value, we check if it's out of bounds, we add it, we rotate R1, and we add that value in, right? Then we go to the next one, we restore this value from the width of the grid, we add it to our cursor position twice, so the first one will push us there, and then the second time we'll add it over there, and we load that value and check if it's out of bounds and all that. And then lastly we subtract 2 from our grid position, which will move us to this here, and we load that one in, right? And then we're going to move R2, we're going to move 3 into R2. Now, because that's going to load from the top left corner and then top right, bottom left, those could be in any order, right? It could be, in this case, it would be MSSM, or it could be SMMS, or SSMM, or MMSS, right? It could be anything. So what I'm going to do, rather than having like writing in multiple variations of what I'm looking for to check in memory against strings in memory, what I'm going to do is I'm going to rotate the contents of R1 to check if it is that gold string, that MMSS up there. So I load, this is what I got here, rotate check, right? So I load in that I'm loading in every time. Why am I loading every time? Don't need to load in every time. I could have put it up like here. Just start twice. Could have put it there. That would have been better. Anyway, so we're going to compare what's in R1 with R0, right? That string up here, right? Where are we? Yeah. If it's equal, then we branch to add gold. If it's not equal, then we're going to rotate it by 8 bits, which will shift the lowest byte into the highest position. Just move everything, rotate everything around. Rotate this, yeah, rotate the bytes around. Subtract 1 from R2, and while we're still positive, we will try again. So we'll try each sort of arrangement of these bytes. Right. So the first time it would check like M, S, S. It would be the contents of the register would be M, S, S, M. Then the second time would be S, S, M, M, I think. Something like that. Or the next time would be S, M, M, S, and then it would be M, M, S, S. Right, as we rotate the bytes around in the register. And then assuming that we find a match, we've matched little branch to add gold. Right, add gold will load the value for result 2, add 1 to it, and store it back into result 2, and then just fall into exit gold. And if we don't find a match, it'll just branch to exit gold. Alright, that's the code. This, I mean, it's kind of verbose a bit, but that's alright. Let's check if it's going to run again now that I've made some changes to it. Alright, it's looking good. Okay, so let's get rid of the browser. There's nothing great to look at in memory this time, so we'll just do a demonstration. Here we are, day 4, and let's run the result, shall we? And that's our result. Alright, so that was day 4. A bit more interesting, looking for like strings in a grid. A little bit more, wow, a little bit more to think about. Alright, so I hope you'll be back again for day number 5, and I'll see you then.